Good afternoon, everyone. I'm Kevin, software engineer at NVIDIA, and today I'll be going over the converter SIG updates over the past year. So on the agenda today, I'll be going over the updates for the front-end converters, the back-end converters, and there will be a slide on how to get involved with the converter SIG. So first up is PyTorch. So the latest release of PyTorch is PyTorch version 2.3.1 plus support for offset 21. And the main things to highlight here is the consolidated API for Torch Onyx export. Previously, when Dynamo export was being brought up, there were two separate APIs, one torch.onyx.export and one torch.onyx.dynamo export, but now it's consolidated to just torch.onyx.export with the flag to optionally enable Dynamo. The main focus for the PyTorch to converter side is to improve the Dynamo export, as the plan is for Dynamo to be the de facto way to export from Torch in the future. So some of these goals include the aim to implement all of the core A10 and the prims, IR ops, improve FX graph capturing by directly calling torch.export to get an exported program, improve error logging so that users can more easily pinpoint where exactly in the whole Onyx, PyTorch to Onyx workflow that an error occurred, and to use Torchbench to keep track of functional as well as performance evaluations as we're slowly switching over to Dynamo exported models. So a diagram of the, high-level overview of what the Dynamo export will eventually look like. First, of course, you start with your PyTorch model. You would call torch.export.export to contain, to get a exported program. And once you have the exported program, there would be a sort of a Torch to Onyx converter that generates a model in the Onyx IR, which was talked about previously in Justin's presentation. Once you have the Onyx IR, there's another tool called the Onyx Rewriter, which optimizes the model a little bit. And then finally, once you have your optimized model represented in Onyx IR, you call Onyx IR serialization to get your final serialized Onyx model that we're all familiar with. And on the side, just to showcase the evaluation framework, with Torchbench, we have automated export scripts into Onyx, and then those Onyx models are being evaluated with Onyx runtime and in order to collect performance statistics. So this is still a relatively new and evolving ecosystem. So just to sort of highlight the main components that go on when exporting from Dynamo. So first you have torchlib, which is a set of functions that essentially convert the PyTorch operations through Onyx script into ones that can be represented in the Onyx IR. And in the Onyx IR, it's an in-memory representation of the converted model. Again, it is separate from the actual Onyx proto itself. And one big advantage of using this Onyx IR is that it reuses the PyTorch weights directly, so there's no extra, there's a very little memory overhead of using Onyx IR. Finally, we have Onyx Rewriter, which again is a library to do Onyx to Onyx transformations, to generally perform common optimizations that are seen across models, and with the benefit of for users to potentially extend it themselves for, let's say, you might need to have a specific rewrite for a specific backend. You could do that as well with Onyx Rewriter. So that's for Torch. On the TensorFlow side, the latest release is TF2 Onyx version 1.16 with support up to offset 18 and TensorFlow 2.15. There are some things to highlight here is the support for tf.resize.area, as well as bool input support for a few other ops as well. One tricky thing working with TensorFlow is because the format is different. There's a lot of transposes necessary to get these models exported into Onyx, which is not channel last. So there has been various efforts to make the transpose optimizer as good as possible. For sklearn, the latest release is sklearn version 1.17.0 with offset 21 support. The latest release supports sklearn 1.15. There's a lot of improved fixes for the one-hot encoder, and there's a sort of a new feature called Add to Onyx Graph, which gives you the ability to sort of wrap Onyx graphs generated from other frameworks in order to import that into your sklearn pipeline. On the backend side for Onyx and TensorRT, the latest release is version 10.1 with support for offset 20. We've added support for a few new operators and a few attributes for existing operators. One large feature to sort of highlight here is the support for weight stripped engines. So essentially, previously you had to compile your Onyx model and ship the entire engine to your user, but now you could ship a small precompiled engine along with your Onyx model, which you may be shipping anyways, and then refit the weights directly into your precompiled engine directly on device. For more data type support, we have native support for Int64 now, as well as support for Int4 quantization. Finally, for Onyx runtime, latest releases, fresh off the presses at 1.18.1. It supports Onyx 1.16. Supports CUDA 11.8 with CUDA 8 and CUDA 12 with CUDA 9, and supports pre-built wheels from Python 3.8 to 3.12. There's been various optimization added for Dynamo exported versions of Onyx models, and there's too many execution providers to list with Onyx runtime. So I just have a link to the EP landing page to get the most up-to-date information. So feel free to get involved if this sounds interesting to anyone here. Feel free to join us on Slack and our SIG mailing list to keep up to date with the updates. And because a lot of these projects exist in sort of their own repositories, there's a lot of different people working on it, and the quickest way to get responses from them is to open up issues and partake in discussions on GitHub. That's everything. Is there any questions? There is it's not officially released yet. It's still in beta mode as we're bringing it up. So at the moment, although there is a unified API, Torch script export is still the default. But users can opt in to try out Dynamo by enabling the flag, and then we highly encourage users to do that to make sure that we are covering all the models that we can. So the question was, with torch.export, does the rewriter run automatically? So the answer to that is, for the Dynamo path, it does. But for the Torch script path, I'm not sure if it does. Oh, so it doesn't right now. So it's only for the Dynamo path that the rewriter automatically runs. But again, there's nothing stopping us from a later API update to say, okay, if the API is unified, we could also run rewriter on the Torch script models as well.
But it's only rewriter, not simplifier.
Yes, only rewriter. Okay. Thank you.